Talk about a waste of space, or a space of waste. Pollutants? Pollution is a hot topic here on the earth. It's something almost every government always brings up in every election. Like, what do we do with the pollution? Or what about this big catastrophic event? Pollution's a big deal, and for good reason. Like, it makes people sick. And nobody wants to be sick. Nobody wants overwhelming amounts of bad chemicals freely being able to enter their bodies, and if not their bodies directly, the ecosystems in which they get their resources. Like, I don't want my lakes and ponds and rivers filled with chemicals, because that's where I get my water. And there's a legitimate amount of concern for the amount of wastes that we have in our environment. So we've got this constant battle to deal with. Like, how do we deal with pollution? So we're going to tackle this with a two-pronged approach. First, we need to even talk about what kind of pollutants are we concerned with, and then second of all, we're going to talk about some of the key strategies that we use to kind of either move the chemicals around in a way that's allows them to be safe, or how do we destroy those chemicals so they again can be safe. Let's chat fertilizer. Fertilizer is used for obvious reasons. It makes farmers' fields more nutritious, better able to grow crops, and we kind of need that food. For them to do their jobs, they need a healthy field. There's a catch. That chemical can make its way into our water systems. And there's a certain plant in those water systems that we absolutely don't want to have access to more nutrition. And that's algae. Algae, they grow in such astounding numbers in a short period of time, which makes them really hard to handle. They can grow to such great numbers that it's called an algae bloom, where you end up choking out the entire ecosystem, to the point where, like, even there's so much algae in the water that it even clogs up a fish's gills. An algae bloom can wipe out a lake or a river ecosystem. So obvious reasons that's not good. So like fertilizers, something we're concerned with. Another one, like pesticides. Pesticides, same idea. It's another chemical that's sprayed on our crops. It can make its way into our water systems, or it can biomagnify in a food chain. Either way, it's another chemical that we're concerned with. Then there's something like fossil fuels. Fossil fuels, this is a lot more of a hot button topic, definitely something that's discussed regularly, and it's the consequence of fossil fuels. When we burn fossil fuels, we put so many different types of gases up into the air, from nitrogen oxides to sulfur oxides, carbon oxides. All of those have some different potential to do some really crappy things. Then there's the stuff that we put into our environments directly. There's two different groups of that. First, there's our like solid waste, the stuff that we put into like garbage bags, and you pack it up, put it on your curb, and then it's taken away to a landfill. That's chemicals that we're directly putting into our environment. Second of all, there's our sewage. We make sewage. It's the stuff we put in our bathroom, whether it's going down your toilet or your shower. There's also like the stuff that goes down your sink and your dishwasher, and then also your washing machine for your clothes. Like, all of that is different chemicals, whether it's like food nutrition or liquid detergent or poop. All of those things have chemicals, and we introduce those into our environment directly. So we put things into the environment as well, not just fossil fuels, pesticides, and like fertilizers, and like there's other things as well. But we sometimes directly contribute to the pollution in an area. So what are you going to do about it? Well, we have a couple strategies. We can either take that chemical and spread it out over a big enough area that the concentration of it goes down enough that it's no longer concerning. That strategy can be employed to an extent. Then there is just like if there's too much of a chemical in an area, we need to find a way of destroying it or removing it. So if I wanted to spread it out over an area, reduce its concentration, there's a couple different strategies we can talk about. First, let's talk about dilution. We can dilute an area, dilute a chemical by adding water. Same like process as diluting anything else. If we wanted to add a little bit of chemical to a river, we could reduce that concentration by adding a whole bunch of water with it. We can flush the chemical. Thereby, if we spread it out enough, it might not be toxic to the organisms that we introduce it to, or perhaps it's not going to overload a system with nutrients or other concerning things. So we can, that's called dilution. Dispersion is a similar idea, but instead of worrying about water, we use air. Dispersion is talking about like what kind of strategy do we use to deal with gases that we're putting up into the atmosphere. So like smokestacks. We burn fossil fuels, and a lot of the stuff that we can't actually capture ends up going up the smokestack and out into the environment. Now, the purpose behind a smokestack is that the higher up the smoke gets released, the farther it will spread itself before settling down onto the land. So if you have it up in the air longer, it will spread further. The benefit of that is when it does settle down, it does it might not be in a concentration high enough to have any real measurable effect on the environment. Both of those things, dilution and dispersion, are not long-time solutions. They're short-term solutions to problems. We can introduce small amounts of the chemical in a way that we know isn't going to hurt the environment, but we can't keep introducing that small amount indefinitely. If we were to do that, it's almost certain that it'll end up backlogging somewhere, or some of the problem is going to manifest itself where we're not actually diluting the problem anymore, and it starts building up somewhere. Like that chemical, it will eventually feed into some river or lake. Like if we're diluting it, that chemical could potentially slowly build up in that lake, and you end up with a magnification of it down the way. That's unacceptable. So we do have some other strategies as well. If spreading out the chemical simply isn't good enough, like say it's a really toxic chemical, spreading it out, like who are we kidding? We're still going to hurt things. So there are some other techniques that we can use. One of them is biodegradation. Biodegradation is the process where we use something like bacteria or fungus that can absorb that particle. We use them as kind of like the sacrificial lambs. We toss them into the soil or in the water or where we know they're going to go in there and clean it up for us, and they go do their job. It's pretty cool. That's called biodegradation, using something living to kind of clean stuff up for us. They use their own chemical pathways to break down chemicals that we don't like. Awesome. Another cool one that we use is something called phytoremediation. Let's say that a chemical spill happened in an area. We know that if we were to plant some plants there, like say the spill happened on some farmland, those crops will eat up that chemical. It'll all get absorbed. It'll either kill the plant or mess up the plant in some sort of way, or maybe it won't hurt the plant but it still gets absorbed. We can use that to our advantage. We can take plants, grow them in an area where we know a chemical is, and get the plants to absorb those harmful things for us, and then we dig up the plants and we destroy the plants. The last method that we're going to talk about is one that's fairly trusty. The sun is powerful. It is magnificent in everything that it does. The types of light that come off the sun is not just visible light. We see only a fraction of the type of light that comes out of the sun, but that sun releases every bit of the spectrum of electromagnetic radiation. It releases radio waves and infrared and visible and microwaves, X-rays, gamma rays. It releases it all. Some of those more severe or more energetic electromagnetic radiation waves have the potential to break things down, like ultraviolet, X-rays. Some of those get through our atmosphere. Not all of them. Most of them are deflected away by either our magnetosphere or our ozone layer. However, some does get through. Those have damaging potential. Simply leaving something in the sunlight breaks it down over time. Think about any toy that you've left outside over the summer. It's faded. You leave it out there for several summers and it starts, like, the color completely goes on it. A really interesting thought is back in the 1960s, 1967, when the Apollo mission landed on the moon, they planted a flag there, and that flag has been exposed to sunlight, unprotected sunlight, for years. That flag is almost certainly pure white now. The chemicals in it have more than likely broken down. The fibers are probably also being affected. The point is that the sun has power to break things down for us. In fact, it's one of the only things that breaks down plastic at all. Plastic over time does break apart. It doesn't decompose, but it can break apart into smaller bits. That's arguably worse in some cases, but maybe not so much. So you end up with the sunlight breaking things down for us, and we call that photolysis. Photo meaning light, lysis meaning to split. So light splitting, light doing splitting for us. So photolysis, another interesting technique in which we can employ to help us deal with different chemicals or different problems. There is one challenge with certain chemicals. Some chemicals are a little bit more difficult to deal with. Something like mercury. Mercury is already an element, so we can't break it down any further. And the second problem with mercury is that we can't really spread it out either. We can't, in good conscience, put it anywhere because it's a heavy metal, and we know heavy metals screw organisms up badly. So we're kind of in this kind of double-edged sword. There's no real way of handling mercury. Our best bet is to just move it around. This is where phytoremediation can be a huge advantage, because bacteria, they don't move things around for us, because if we put that bacteria into a soil, it might absorb the mercury, but we can't just pluck the bacteria right back out. So when they die, they're just going to put the mercury back into the soil. Plants, though, if a plant can absorb that mercury, we can absolutely take that plant out and move it to a different spot and deal with it. So some things are just harder to deal with, and sometimes one solution isn't the only way to approach it. Sometimes we need to use a combination of our techniques to come up with the best way of handling serious chemicals. Let's wrap up. There's lots of chemicals in our environment that we have to be concerned with. Pesticides, fertilizers, fossil fuel emissions. There's tons of them. However, However, we're concerned about these chemicals. We have come up with some really cool technologies and great ideas on how to handle those technologies, or those pollutants. So we came up with two kind of classifications of strategies. One is to spread those chemicals out. The second one is to break them down in some way. So spreading them out, we do that through two techniques, dilution and dispersion. Dilution is to add a whole bunch of water to the system, which lowers the concentration of the chemical. Dispersion, same idea, but up in the air. We spread out the chemical over a greater area. We're going to have less of a concentration in the immediate area right next to it. Then there's ways of breaking it down. There's biodegradation, photoremediation, and photolysis. So biodegradation is using some sort of biological process to break things down, like bacteria or fungus. They do a great job of breaking down certain chemicals, but obviously not all. Phytoremediation is the use of plants, phyto meaning plant. So using plants to try and absorb things, and some plants can break down some of that stuff, or we can just absorb it using the plants and then remove the plants and destroy them. That is still a great way of getting rid of chemicals. And then finally, photolysis is using straight up sunlight to break things down. Sunlight has some powerful energies in it, not just the visible light that we see and use every day, not just the infrared that helps heat us up. Sunlight also can provide those X-rays and ultraviolet rays that can be damaging to things, and some things we want to get damaged, like harmful chemicals. That's all for today. Thanks so much for watching. Till next time.